About the intermediate value theorem to show that the two graphs y is equal to e to the power of x, okay, and y is equal to negative x, they intersect. Okay, so how to show they intersect? They intersect just means that e to the power of x is equal to negative x has a solution, right? These two functions, they intersect. It just means e to the power of x is equal to negative x have a solution. Okay, which also means for the left-hand side, you can rewrite it as e to the power of x plus x equal to 0 has a solution. Right? So these two are the same thing. So we can call this left-hand side, we can call this fx. Okay, we can call this left-hand side fx. Then we want to use the intermediate value theorem. Okay, we want to know it's equal to 0 has a solution. So by the intermediate value theorem, what is intermediate value theorem? So if a function fx is continuous, okay, if a function fx is continuous on the closed interval ab, okay, and let's say fa and fb, right? For the two boundaries, you have two values, fa and fb. So if there's a value, okay, let's assume fa is smaller than fb. Right? It doesn't actually matter. Fa could be larger than fb. Fb could be same as fb, but it doesn't actually matter. But let's assume fa is smaller than fb. Then, you know, for a value y0 such that, okay, for a value y0 which is between fa and fb, so let's say y0 is between fa and fb. Okay, for any such value, for any y0 such that y0 is between fa and fb, there must exist there must exist an x0 right in the interval, in the open interval ab, such that okay, fx0 is equal to y0. Okay, this is the intermediate value theorem. Okay, so what's the meaning of it? What's the intuition behind it? So actually, if you draw the graph, it's very easy to understand. So let's say this is my point A, this is my point B, right? This is my point FA, this is my point FB. Okay, so you already know these 2 points, AFA and BFB. They are on the graph of fx. Okay, but you don't know, what you don't know is, right, what does this function look like? You know, it could be as simple as a straight line. It could be a curve, right? It could be any curve, right? It could be any type of function, right? Up and down. It could be whatever function, right? But no matter what function you draw, let's say, for example, this point is a y0, okay? No matter what function you draw, for example, you draw this function, then you can find a point between a, b, right, such that fx is equal to y. Right? If you draw a function like this, if you draw a function like this, you can still find a point between a and b, right, such that fx is y. Or you draw the function like this. Okay, or sometimes you can even find 2 or 3 or multiple points. And now you can find actually 3 points between a and b, giving you this y value. Okay, but the point is there is at least one. Okay, why there's at least one? It's very simple. You try to connect these two dots, your line or curve, whatever, will always pass this line, right? as long as it's continuous, no matter how you connect them, right, no matter how weird the shape is, you're always past this point. You're always past this line. Okay. That's the intuition behind this. Okay, so let's see. How can you prove? So back to the question, how can you prove e to the power of x plus x is equal to 0 has a solution? Right, how can you prove this has a solution? So you want to find 2 points. One point giving you an fx value positive. Another point giving you an fx value negative. Okay, so for any positive, let's just try f1. Okay, f1 is e to the power of 1 plus 1. It's just e plus 1. You know, it's 3.7 something. Okay, it's positive. Right? To find something negative, let's just try -1 or any number. As long as it gives you a negative f value, it's fine. But let's say if I try -1, it's e to the power of -1 minus 1. Here's this part. It is a 0 point something, right? I don't care. It's a 0 point something. -1, it's going to be a small number. It's going to be a negative number. So this part, it will be smaller than 0. Okay. So now you find 2 points, right? One point gives you a value positive. Another point gives you a value negative. So now you can use IVT. So fx, first, it's obvious that it's continuous. Okay, it's continuous on the interval -1, 1. Okay, you don't even need to prove this because it's e to the power of x plus x. Right? It's a combination of some basic functions. E to the power of x, a very basic function, continuous, and x, right, a polynomial, continuous. So fx is continuous on -1 to 1. And your f1 is positive. Your f -1 is negative. Right? So both conditions are satisfied. Then by IVT, by the intermediate value theorem, there exists an x. Let's say it's an x0, okay, between -1 and 1. So let's say it belongs to this interval. Let's say there's an x0 belongs to -1 and 1, and now it's an open interval. Okay, such that fx0 is 0. Okay. So you've proven that there's an x between -1 and 1 such that fx0 is 0. So that x0 is going to be a solution of fx is equal to 0, right? That x0 will be a solution. Okay. So do you have any questions for this one?